All right, so as my objective says on the board, we're going to find the area between two curves.
Can I guess how to do it?
We'll try to find
Yes.
it.
Okay. Let me talk about what we want, and then I'll let you have at it, Abby.
All right.
So I have a curve here. I have a curve here. I'm interested in the curve or the area that's trapped in between. All right, Abby, take it away.
Well, see, I was looking at the one on our paper, so I'm a bit lost now.
Oh, wait, can you
I can tell you what I was thinking for this.
Well, tell me what you were thinking for that, then.
Okay, so, well, you see this curve B line?
The top curve.
Yeah. And then, so just, do the integration thing, find the area under that curve, and then find the area under this straight line, and then subtract them, and then you get the one in the middle.
Bang. There it is. Everybody follow her?
No. Literally, no.
She's saying we have this top curve right here. So we want to find the area under the top curve here. Then find the area under the bottom curve, which is here. Subtract the two, and then that gives me that curve. Okay?
That's a lot of work.
So a better visual. So there is the area underneath the top curve.
But why is it only that with the rest of the stuff?
In between negative 1.
Because I only want the area that's trapped here. So the farthest left, that's where I'm going to go. Farthest right, that's where I'm going to go. Of the trapped areas. I don't care about the area anywhere else.
Can you pick that one? It's so nice.
It looks like a flying blueberry.
All right, so there's the area of the top. There's the area underneath. If you subtract the two, you end up with the area that's trapped. Okay? So let's call the function that's on top f1. Let's call the function that's on the bottom f2. So you're telling me I want to integrate. I think you identify that it's negative 1 to 1. The top function, which would be f1 of x dx, and then we want to subtract the area from negative 1 to 1 of f2 of x dx is what you're telling me. Okay? Can I make this simpler than I have written up here? What? I can combine them into one integral. So f1 of x minus f2 of x, and then that's going to give me my area that's trapped. Okay? How do you determine which function comes first? Doesn't have to be concave down. The one on top. So the top function always comes first. Bottom function always comes second.
I said top.
When you integrate that, that's going to give you the area that's trapped in between the two functions. Can you buy that?
Yes, sir. I can tell
Good.
you guys.
All right, so let's get to what you have in front of you. All right, it says let R be the region bounded by the graphs of the square root of x and y equals x over 2. So that means R is the area that's trapped. Okay? We want to find the area of R. So raise your hand if you can set this up for me. Okay?
Okay. And I don't know what those values are, but I know it's going to be square root of x minus x over 2 dx. And then would it be like 0 to 4?
0 to 4. Okay, how'd you know the square root of x was on top?
Because that was the first one given.
Because it was the first one given? It's not always going to be that
I
way.
don't know.
It's not always going to be that way. How can we identify that the square root of x is the one that's on top?
That's the top function, and you know that root x looks like that.
All right, so you know the square root of x looks like half a parabola. But let's say I have no clue what these two functions look like. What's something simple I can do to figure out which one's on top?
Plug in an x.
Plug in a point is a great answer. So all I have to do is pick an x value in here and plug it in. Whichever x value produces the highest y value, that's the one that's on top. So let's plug in 1. If I plug in 1 here, I get the square root of 1, which is 1. If I plug in 1 here, I get 1/2. 1 is bigger than 1/2, so that means this function's on top. So if you can't tell just by looking at it, all you got to do is plug in. That'll tell you which one's on top. With me? All right, so then it's just a matter of finishing it up. So if I integrate the square root of x, what do I get?
That's huge.
1 over 2 square root of x.
I get 3 halves
Never mind.
and 2/3. Remember, x over 2 is the same thing as 1/2 x. So I've got my 1/2. The x is going to turn into an x squared, and then I need another 1/2, and we go from 0 to 4.
Why do you use another 1/2 that?
Because when I integrate x, it gives me x squared, and then I have to divide by it.
1/4.
Right, it's going to be 1/4.
Okay.
I'm just trying to show you as much as possible. All right, so then we plug in 4. So 2/3, 4 to the 3 halves, minus 1/4, 4 squared. And then when I plug in 0 into both of these, I'm going to get 0. Now, if this is a free response question, at this point, you've done everything they've asked you to do. Okay? You do not have to go any further. So you're allowed to stop here. Make sure you understand that. Okay? Let's go ahead and keep going though to get a simplified answer. All right. What does the 3 halves want me to do to 4? Square root and cube it. So the square root of 4 is 2. 2 cubed is 8. 8 times 2. So that's 16/3. Over here I get 16 divided by 4 gives me 4. Common denominator, so 3 times 4 is 12. 16 minus 12 gives me 4/3. Raise your hand if you can tell me what 4/3 represents. Elias?
The area under the y equals square root of x but above x over 2.
All right, so that is the area that is trapped right here between my two functions. Very good. Haley, go. So we're finding area between two curves. Questions on that problem? So the problem on there was a problem similar to that on the AP mock. Anybody figure that out on your own?
No.
Probably not.
Is that like the
Oh, that's what
the
that
E?
is.
It's like number 5 on the free response. It was like
Yeah, I
I
didn't
think
really
so,
do any
yeah.
of those for your response.
Yeah, number 5, part A.
Is that like the dot one?
Say it again.
You get the 2 dots. Is that the right one you're talking about?
No.
Probably not right.
You know the 2 dot? You know that question? Like, it was like 5 or 6 had 2 dots on the views or something like that.
Oh, no. That wasn't that problem.
Could we do that one up there in the Rocky then?
Did you do that one during the
No,
mock?
could we have done it? That's what we do.
Yes. That's just related rates. Is all that problem was.
Yeah, well, Zach didn't do it. He didn't do that.
Don't fall asleep. I did that.
All right, next one. Says let R be the region bounded by the graphs of y equals x squared. Is that negative x squared?
Yeah.
Negative x squared plus 4x plus 2. And the graph of y equals x plus 2. Find the area of R. So I want to find the area that's trapped. So what do we not have here? We do not have a graph. Okay, but we can still figure it all out even without drawing a graph. Ivan? Set them equal to each other. Okay, somebody else tell me what setting it equal to each other is going to do.
I don't know.
Natalie? No? No?
Is it going to give you your bottom and top numbers?
No? That's what Natalie was saying. Haley, what's it going to tell me? If I set them equal to each other and solve. Zach, what's it going to tell me?
Your inter- like your
Yes.
interval, whatever.
Yes, it's going to tell me my interval. That's going to tell me where I'm going to start and where I'm going to stop. It's going to give. That's not what you said. You said which one's on top.
No, like the bottom and top numbers on the little.
I was thinking.
I misunderstood you. I thought you were talking about which one's on top and which one's on
Oh,
bottom.
no.
All right, so whenever I set them equal, I'm finding the intersection points, and that's going to tell me left to right, or in my integral, top to bottom. So that's the first thing I want to do here is set these equal to each other. All right, so negative x squared plus 4x plus 2 equals x plus 2. Since my x squared is negative, I'm going to move everything to the right side because I like my x squared to be positive. So that's going to be minus 3x, and then the 2's cancel, correct?
Yes.
So we factor, and we see that our intersection points are the x values of 0 and 3. So I know I have the integral from 0 to 3 over here.
Does it matter which? You have to put it a certain way what you find, like the order. Like, does it matter what's B and what's A?
Smallest numbers on the bottom.
So you get to choose which number. A lot of times. Never mind, I'm not trying to say.
Smallest number is always on the bottom.
One.
Alright, what do I need to determine next? Which
Which
one's on top? Advait, how am I going to determine which one's on top? Plug in a point. So I need to plug in a point between 0 and 3. Easiest one to plug in is 1. So if I plug in 1, I'm going to get -1 and 4, which is 3. 3 plus 2 gives me 5. Plug in 1 there, I get 3. Which one needs to be on top? The first one. So negative x squared plus 4x plus 2 minus, make sure you put that second function in parentheses if it's something other than a monomial. Okay, because what are you going to forget to do?
Apply the negative.
Distribute the negative, so make sure you distribute. Alright, let's clean that up. So negative x squared, I'm going to get 3x and 2's cancel. So now I'm ready to integrate. So negative 1/3 x cubed plus 3/2 x squared, 0 to 3. Okay, plug in 3. So negative 1/3 3 cubed plus 3/2 3 squared. And what happens when I plug in 0? 0. Now again, don't just assume you're going to get 0 because you're plugging in 0. Make sure you think about, am I really going to get 0? Alright, so 3 cubed is 27 divided by 3. So negative 9 there. This gives me 9 times 3. 2 times 9, 18, negative 18, and 27. So I end up with 9/2.
Wait, where did the 0 come from?
This 0,
Yeah.
when I plug 0 into both of these, it gives me 0.
Oh, so you're doing like down, back to this?
FTC is what I'm doing there, yes.
Question.
Okay.
When you like have like a fraction like that and stuff, and like one without a fraction, is it always going to end up where it's like that number over whatever's on the bottom? Does that happen on both?
Not necessarily, but it does happen quite a bit. Alright. So, Haley, what does this 9/2 represent?
R.
Which is
Area between the two
area between the two graphs.
graphs.
Very good. Now, notice the area I found on the first problem and the area I found on this problem were both, they were positive is the word I'm looking for. Okay. Whenever you're finding area between two curves, they should always be positive. What does it mean if you go through this process and you end up with an answer and your answer is negative? That means your bottom and top are switched. That means you have it backwards. Okay, so you need to go back, switch it, and then work it again.
What if like where it is on the graph it's negative? Like,
Doesn't matter. It's always going to be positive. Okay? Alright, so that's finding area between two curves.
It's pretty easy, honestly.
It is. Alright, so if you do not have a graph, what's step 1? Set them equal and solve. What does that give you? Your limits. Gives you your bounds. Okay, then what do I have to decide?
Which one's top?
Which one's on top, which one's on bottom? How do I determine that?
Pick an X value within your.
Plug in an X value. Whichever one gives me the highest Y value, that one goes on top, or goes first, and is on top. Put the other one there, clean it up, integrate, plug in. You should get a positive value, and that represents the area between the two curves.
Do we?
If you
Yes,
can
it is.
see,
Oh, I see it.
like if you have a graph and you can see it on the graph and all the stuff is under the x-axis, is the like the one that's actually visibly on top, like closest to the x-axis, that's still going to be the first one that you put.
Right, it does not matter whether or not the region is above the x-axis or the region is below the x-axis. The top function is always going to come first, and the bottom function is always going to come second. and it will always produce a positive area.
You put in the X has the integer in the
Yes, when you're trying to figure out which one's on top, yes. Everybody hear Haley's question? It was a good question. She was saying, when you plug in to figure out which one's on top, does the X value always have to be in your interval? The answer is yes. Your X value you pick to figure out which one's on top always has to be in your interval. Good question. Any other questions on finding area between two curves?
No homework, right?